Alright, welcome back to section 4.3, but instead of around the origin, today we are doing rotations around a fixed point. This one's a little bit more involved than rotating about the origin, so let's make sure we're paying attention today. Learning attention, I am learning how to rotate a figure about, I'm going to cross that out and say a fixed point on the coordinate plane and describe how the rotation changes its position while keeping the size and shape. Again, rotation is a rigid transformation. The size and shape does not change, just the location on the graph. So hopefully by the end of this lesson, and we're going to really concentrate on that first one, I can accurately identify and describe rotations in the coordinate plane, whether it's 90, 180, 270, all that. And I can identify and perform a sequence of rotations about a fixed point that maps a given figure onto itself or another congruent figure. Again, if you're doing that by the end of this lesson, you are doing absolutely fantastic. I'm going to go through, like usual, a little example here just to show how this really works. So we're going to look at triangle XYZ with these vertices. We're going to follow these steps on the left to find the coordinates of an image under a 90-degree counterclockwise rotation about 0.12. So instead of having our origin, right here, that dot right there, be our point of rotation, now it's going to be 0.12. And that's really important for us. So we're going to plot XYZ real quick. We're going to go 4, 7. So 1, 2, 3, 4, 5, 6, 7. They actually gave us a graph that's 10 by 10 this time. Y is 8, 5. And Z is 6, 3. So we'll make our triangle there. So we have X, Y, Z. Alright, so we graphed XYZ in the center of rotation, P. Let's make sure we label point P. Now what we're going to do is we're going to write the vectors formed from the center of rotation to each vertex in component or vertex form. So what that means is we're going to, that's why we have all this space on this problem over here, is we're going to figure out how far is it from P to X, and how far is it from P to Y, how far is it from P to Z in our vector form. And all that means is, again, putting it in these little arrows here, figuring out the left and right for our X and our up and down for the Y. So all these go right and up, so that means everything is going to be positive. We don't have to worry about any negatives. And we're just going to count it out. From P to X, 1, 2, 3. So 3 right. 1, 2, 3, 4, 5 up. That's how we get from P to X. How about from P to Y? 1, 2, 3, 4, 5, 6, 7. Up 3. 1, 2, 3. P to Z. 1, 2, 3, 4, 5. And then up 1. That's the distance, that's the vector of P to X, P to Y, and P to Z. We are now going to do a 90-degree counterclockwise rotation. So if we think back to that last part of the section, a 90-degree rotation means we flip our points, make the first one negative. We're going to do the same thing to the vector. We are going to flip the vector, so 5, 3, make the first one negative. Flip the vector, make the first one negative. Flip the vector, make the first one negative. This is what we are now going to use to plot our image, the x prime, y prime, z prime. We're going to go we're going to use these from P to get our new x, y, z. So this was x, y, z. These are not the points of x, y, and z. This is how we're going to get there. We're going to go from point P. We're going to go -5. So is that left or is that right? It's negative, so it's left. So we're going to go left 5. So 1, 2, 3, 4, 5. And then y is 3, so that's our up. 1, 2, 3. That is our new x. Now where's that at? On the graph. We got to, again, count it out. 1, 2, 3, 4. So that's -4 because we went left. 1, 2, 3, 4, 5 because we went up. Now let's figure out what y is. -3 means we're going left 3. +7 means we're going up 7, and that is from point P. So 1, 2, 3, left. 1, 2, 3, 4, 5, 6, 7. Up. So that should give us -2, 9. And finally, our new z, z prime, -1, 5. So left 1, up 5. So left 1. 1, 2, 3, 4, 5. So we have x prime, y prime, z prime, and z was at 0, 1, 2, 3, 4, 5, 6, 7. So there is that extra step here of having to find that vector from our point of rotation to those original points. That's something that you're going to have to do anytime they say rotate about a certain point. Alright, so let's try another one of these together, and then I'm going to give you that last one to do by yourself. So we have parallelogram ABCD with those vertices, 90-degree counterclockwise rotation about P4, 1. So here's our point of rotation. Now let's graph the actual figure. So we're at 6, 8. So if that was 4, this is 6. 2, 3, 4, 5, 6, 7, 8. Back to a weird graph. 10, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 9. 9, 3. And 5, 2. Okay, so that should be 5, 2, 9, 3, 10, 9. Yep, graphed it right this time. A, B, C, and D. Now we're going to figure out the vector from P to the rest of these points. So we're looking for PA, PB, PC, and PD. Notice how once again we got lucky. Everything is right and up, so we know everything's going to be positive right now. We just got to figure out how many to the right and how many up. So P to A, 2 to the right, and then up 1, 2, 3, 4, 5, 6, 7. B 1, 2, 3, 4, 5, 6. And then we have 8 up. PC, we've got 1, 2, 3, 4, 5, and 2 up. And then PD, 1 and 1. Now, Something you may notice, we don't necessarily have to graph here. If you're given your point of rotation and you're given all your points, all you have to do is look at the points. How do you go from 4 to 6? Plus 2. How do you go from 1 to 8? Plus 7. How do you go from 4 to 10? Plus 6. 1 to 9 is 8. 4 to 9 is 5. 1 to 3 is 2. 4 to 5 is 1. 1 to 2 is 1. So, you don't want to graph. Technically, you don't have to. It's up to you. We are doing a 90-degree counterclockwise rotation just like we did in the example above. So that means we have we're changing it from xy to negative yx. So we're flipping it, making the first one negative, just like we did before. So, flip it, make the first one negative. 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 Now from point P, we're going to get all our new answers, our new points. So, from point P, we're going to go 7 left, up 2. So 1, 2, 3, 4, 5, 6, 7, up 2. For point B, we're going to go left 8, up 6. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6. For C, left 2, up 5. Yep, counted that right. And then for D, 1 and 1. Now let's figure out where these points are. Here's where A prime, B prime, C prime, D prime. That puts us at A at 1, 2, so that's negative 3 and positive 3. B is at negative 4, 7. C is at 2, 6. And D is at 3, 2. Now again, if you didn't have a graph, it's not the end of the world. Take your vector from point P. What's 4 minus 7? Negative 3. What's 1 plus 2? Because again, now it's negative, that's positive. So we're subtracting, we're adding. 4 minus 7 is negative 3. 1 plus 2 is 3. 4 minus 8 is negative 4. 1 plus 6 is 7. 4 minus 2 is 2. 1 plus 5 is 6. 4 minus 1 is 3. 1 plus 1 is 2. You don't have to have the graph done, but it's good practice. Right. I want you guys to try number 2 down there at the bottom, and we'll come back together and see how you did. Pause the video. So how do we do on number 2? Did we get 7, negative 2, 4, negative 1, 6, 5, and 9, 4? Again, when you found the vertex form of our 4 lines, you should have got negative 5, negative 1, negative 2, negative 2, negative 4, negative 8, negative 7, negative 7. How do we know that? From 2 to negative 3, we got to subtract 5. From negative 3 to negative 4, you got to subtract 1. From 2 to negative 2, you got to subtract 2. From negative 3, from negative 2 to 0, it's negative 2. From negative 3 to negative 5, it's negative 2. From negative 2 to negative 2, it's negative 4. From negative 3 to negative 11, it's negative 8. From 2 to negative 5, it's negative 7. From negative 3 to negative 10 is also negative 7. 180-degree rotation tells us that we're just going to make everything negative. all of our vertex form was already negative, so we were just going to make everything positive. So 2 plus 5 is 7. Negative 3 plus 1 is negative 2, and so on. Again, it's a little bit more involved than rotating about the origin, but at the end of the day, it's really not that bad. If you guys have any questions, please make sure you're asking. You should now be able to do all of the 4.3 part of your ALEKS assignment. If you have any questions, please ask.